welcome everybody to week 9, day 3. Let's first of all go over the dungeon delve assignment. I'll just show you the answer real fast. So my implementation I did it in about half an hour, so don't expect a whole lot out of it. This is from what we're about to talk about today, huh? Yeah, so that's the whole main. And let me complete these things here. So, basically, this is not a great solution. The way that I showed you to do it last week is a better way. You create a tree class. The tree class has inside of it a node class. This is just leaking pointers from the tree class into main, so main needs to know about the internal details of this tree, which is terrible. It violates the EDT principle, but I don't care. I wrote it in literally like half an hour, so it's probably educational or something. I don't know. So it starts off by just declaring a node pointer. It's actually kind of similar to how the Bridges people did it. The Bridges people don't have a tree class. They just have a node class for each point in the tree. Each point in a tree is a tree, so it's a tree class. So I basically make a root pointer that's null, and then I read a character at a time. Char x, it's a character. I read a character at a time from the standard input. If an error ever occurs, we quit. If we ever get a digit, that moves us into phase 2, because remember the first phase of Dungeon Delve is like ABCD 1, 1 indicating the end of the first phase, and then you do a second series of characters for the password. And so that just breaks us out of the first loop. And then this is just going to build the tree. So if root is null, then it creates a new root. This is not, like I said, it's not great practice. At the same time, like if you look at the Zybooks, the Zybooks does things like this, and the Bridges people do things like this. So it's not the end of the world. So we just knew a new node of chars, and so your code's probably not templated. You probably just had a node class, and the node class has a data of type char. I templated my code, and that's the topic of our lecture today. Actually, is this beautiful little thing right here, and we'll get into that in a little bit. Basically, my BST class, my node class, will work with any data type. It'll work with chars. It'll work with ints. It'll work with strings. It'll work with submarines. It'll work with anything. So we're going to get into how to do that, the syntax on how to do that in just a little bit. You got to do the Zybooks before the assignment. Yeah, it helps. It does help. Got lost in the visualization part. We were supposed to make our own BST using Bridges. Yes. That was the second half of the assignment. So you do it once using your own class, then you do it again using the Bridges stuff. Okay, so if root is null, then we knew a root. Otherwise, we will insert into root, and that does the BST insert for us. I'll show you the code for that in a little bit. If they typed in no characters, we just quit. And then we go into phase 2. So we're going to read the letters one at a time from the keyboard. And if an error occurs, we quit. This is... I left this in here just to show it to you. It's not necessary. What this is saying is if root is null, or we couldn't find the letter in the dungeon, then we're going to print out not solvable. Now this isn't necessary because I'm actually checking up here, right? So I don't actually need to check every time. But it doesn't hurt. But like the reason why I had that in there is because this is something called short circuit evaluation, and you will see this construction. You will see this kind of code all the time when working with pointers. And the way that it works in C++ is that if you have an and or an or, if you have an and or an or, there's a possibility that it doesn't actually look at all the different parts of the if statement. If it knows that the thing is going to be true, or if it knows that it's going to be false, it just stops there and it doesn't evaluate the rest. And so this is a very useful tool to do with null pointers. So what this is doing is saying if root is null, then it immediately stops. It does not do this dereference. This will not segfault. If root is null, that is true, and anytime you have an or statement, if either side of an or statement is true, the whole thing's true. It does not need to do the right-hand side, and it doesn't. Guaranteed it will not do this. It will not do the dereference here. And so it's a way of doing a null pointer check and using a pointer at the same time. Very common construction when working with pointers, because you always have to check to see if a pointer is null. And so we just combine them using short circuit evaluation like this. So if root is null, or we couldn't find the person in question, we print out it's not solvable and quit. Otherwise, we add the letter to the vector. And then, I don't know why I did it this way. It's just probably to get the printing working the right way. And then I say for every letter in the vector, it's a vector of chars or a string, more or less the same thing. Strings do a little bit extra, but I'm just calling it vec because I'm just using it as a vector of characters. So for every character in vec, we print out the directions, and then at the end we exit, and I delete root, and then root cleans itself up with its destructor, and that is the entire assignment. You had over a week to do that, I think. So, is recursion necessary to deep copy a tree? Recursion is never necessary. Would I do it that way? Probably. Yeah. Whenever you're working with a tree, recursion is like usually the way to go. Now, there's a danger of that, which is that if you recurse too deeply, you can run out of stack space. And so the size of the stack on your computer determines how deep into a tree it could recurse until it runs out of stack space and crashes. So it's a trade-off. You know, if you have a balanced binary search tree, it's not going to be an issue. If you have an unbalanced tree, I wouldn't do it. I wouldn't do it in practice. Like, I wouldn't do it in like actual professional code, because you can't recover from running out of stack memory. It just kills your program. There's no hope for you at that point. So if somebody feeds you an unbalanced tree, A, B, C, D, E, F, G, you know, and it just creates essentially a long linked list, when you recurse down that tree, every time you go a layer deeper in the tree, it's eating up more stack space. And so depending on how much stack space you have, you could easily run out of stack memory. So something to pay attention to whenever you do recursion. But recursion is never technically necessary. You can always emulate recursion using a stack container and just push values onto the stack and pop values off the stack manually, essentially, using an actual stack data structure instead of the stack, if that makes sense to you. So let's not save that. I'm going to show you something a little bit. So this is my tree class. The tree class is basically the same code that I gave you before. You know, you insert something. If you have a match, it quits. No duplicate. Go to the left. Go to the right. You know, this is a recursive insert, by the way. So it recursively calls itself. Oh, yeah, that's old school. Null. Yeah, I don't know why I did that. It should be null pointer, right? I use null pointer in main. I don't know why I didn't do it in tree. But yeah, null, 0, and null pointer are all the same. Right. 0 or null pointer. Null pointer is correct, by the way. Null pointer is what you always want to use. So that's our insert. It's the same code that I gave you. The search is the same code that I gave you. I just added cout statements into it. So like as you go down the tree, you go left, you go right, it just prints out, take the left, take the right. That's it. That's the whole code. That's the assignment. Sans the bridges part of it. So, deep copying a tree. Yeah, if you're going to make a professional tree class, you're going to want to have a copy constructor, and you have to do a deep copy to copy all the elements over. So that's it. So it's about 2 pages of code. Don't be depressed by that, by the way, if you couldn't get it done or if it was hard for you or things like that. Linked lists and binary search trees are the hardest things in this class. Like understanding recursion and pointers and all that stuff is just something that everybody goes through. You know, it's just a painful process. Now, what I wanted to show you, our topic for today, is this. So, this is some new C++. This is a part of the core C++ language, has been since, I don't know, the 80s or something. And what it allows you to do is if you add template class T to the line before a class or a function, it allows your class or function to work with any data type. Okay? We Python now. Like the variable noisy, yeah. So I have one, like, I search the tree first without printing anything, and then I search it again with printing things. So I just pass in a Boolean to it whether or not I want to print the steps we're taking or not. So this thing right here is incredibly important in C++, and that's our topic for today. So rather than having to write a binary search tree for characters, which is what most of you did for your homework assignment, and then having to write a binary search tree for integers, let's say if we give you an integer assignment, and having to write a binary search tree for strings, and having to write copy, paste, copy, paste, copy, paste, copy, paste. And every time you copy and paste it, you do a control F, search and replace, okay, I have a binary search tree for ints, and now I need to search and replace integer with string, and then it breaks because somewhere within your code, you've got like an integer for size or something like that. And now you search and replace that, and now that's a string. And unfortunately, string size equals 0 will compile, but when you use it, it segfaults, and forget about it. Okay? Nobody wants to copy and paste code, right? The guy who invented templates, a guy by the name of Alexander Stepanov, is a Russian researcher, and it was his job to copy and paste code and come up with a different version of functions for basically every built-in type. Who did he work for? He worked for HP for a long time, I think. I don't know where he's working now. I think it was HP at least. Yeah, he developed it at HP. He is the guy who did the STL, like what you're using now with like vectors and things like that. That's it. So he started at HP. He had earlier been working for Bell and the Notion of Concepts, which is now in C++ 20. He taught at Adobe Systems. He retired. Okay, so he retired now. So, yeah. Standard template library. Yeah, so basically Stepanov got food poisoning. And he was kind of sitting there. I can only imagine having one of those, this is my life now moments, right? Where, your stomach's getting pumped and there's fish coming out of you in every direction. And I don't even know if this story is true or not. Whatever, it's a good story. And so, he's got to sit there and rewrite functions for, absolute value, right? And he's got to write a version of absolute value, right? Come back to that in a second. So in C you can't do operator overload. You can't do any overloading actually. There's no operator overloading. There's no function overloading. There's no polymorphism. And so if you want to make a function called abs, right? That's cool. All right. If x is less than 0, return -1 times x. Return x. Right. That's cool. But you can't make a function named abs for floats. This is not allowed. This is not allowed in C. Okay? It's not allowed in C because you cannot have two functions with the same name. C++ allows this. C++ will allow overloading a function where you can have multiple functions with the same name. One of them takes an int, one of them takes a float. In C world, that's why they have a function called fabs. Okay, and fabs, of course, takes a double, right? And so this is now okay in C. Okay. Can you imagine being the person whose job it is to come up with a version of absolute value for every built-in type? Short, long, 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 unsigned long, long, unsigned short, float, double, byte, or unsigned char, right? Char. Can you imagine? And it's the same code for every one. You know what I mean? What are ADA generics? They're similar. Generics is what we're learning. Templates is called generic programming. Unsigned chars are a thing, absolutely. They hold numbers from 0 to 255. Chars are integers, by the way. Chars are an integral type. They're not really for letters, even though we kind of pretend they are. Chars are not really letters. They're actually 8-bit integers. And we just pretend that they're letters, unfortunately. It causes problems. So, can you imagine? And then you want to make a version for floats, right? So you come up with floats, but then you realize fabs is already taken. True story. True story. So you have to make fabs with an extra F, right? And then, like, this is your life. You're just making one version of these flabs. Yeah. It's horrible, right? And here's the thing, right? Like, none of these functions are different, right? It's the exact same bloody function for each of them, right? So why would you? Like, this would be so tedious. Like, I would just hate life, right? So dabs for double. Yeah, for whatever reason, fabs is the double version, and if you have the float version, it's fabs, which is like, why? So, what Stepanov realized was that he wanted to write this function once, right? He wants to write absolute value once, and he wants that one version of absolute value to encapsulate the notion of absolute value, right? And he wants to write swap, where you take two values by reference and switch their internal values. He wants to write swap once. And he wants that one function to basically convey what it means to swap two values, and the actual type doesn't really matter, right? Swapping the value of two integers and swapping the value of two floats is really the same thing, right? It actually doesn't matter what their type is. It just, it's going to be the same 3 lines of code every time, right? So here's how you do it. If you want to write one version, it works like this. And I'm going to call this one Bill's absolute value, just because I don't want to conflict with the standard library. And you do it like this. You say template class T, or you can say template type name T. These two things are exactly the same. There's literally no difference between the two. It's just whether you want to type more letters or less. Most people type class for that reason. But if you're not planning on taking a class type, I guess you could use type name to kind of indicate that. I don't know. They're exactly the same. There's no difference. And then here's where the magic comes in. Those integers are now t's, and what t means is figure out the type later. So t is convention. You don't have to call it anything you want. You can call it, I don't know, Wonka or something. If you really hate your successors at the company, that works too. In computer science, though, we always use t. Okay. And so what that means, what this code means, is this is an absolute value function that will work with literally any type. Okay? And so when you call the code like this, like if you want to see out Babs, you can specify in brackets here, I want to do the integer absolute value version of it. Okay? All of you should be pretty familiar with this whole angle bracket thing. You've been doing that all along, right? Vector of integers, vector of strings, vector of doubles, set of characters, right? You've been using templates all along. You just didn't know what it was called, right? I posted the meme, the astronaut meme, right? There you go. You've been using templates for like almost a whole year now, right? Just didn't know about it. And so whatever type you put into the angle brackets here is the type that gets substituted in for t. And so it gets substituted in here, it gets substituted in here. And so this is as if I had written int babs int t. the compiler will literally copy and paste that whole function and substitute t with int. It's like a Mad Lib, if you guys have ever seen Mad Libs before. So a Mad Lib is like a fill in the blanks kind of kids game. Lunchtime in our cafeteria is always adjective. They serve hot food, right? And so you can think of the t as like a blank. Okay, you can't compile template code for that reason. There's actually no, you can't compile it because there's no type, right? And so when you do something like this, what happens is the compiler will literally copy and paste this code. It'll go like copy, and it'll go like paste, and it will say like, okay, he passed an int as the type parameter, and so this is going to be int, and that's going to be int, and there we go. And then if I call Bill's absolute value for, I don't know, doubles or something, you can still take -10, I guess. Then it will copy and paste this code again and generate. It's basically doing what Stepanov used to do professionally, right? Just copying and pasting things a whole hell of a lot of times, right? So it basically, this line of code here causes the compiler. You're never going to see this code. It just does it secretly, right? But it has the compiler secretly generate this for it, where t has int substituted in. Whatever template parameter whatever type you put in as a template parameter, that substitutes in for t. And when we do it for double, it will copy and paste it again and generate the code for you, and yay, everything works. And so you will never see this code. This is all secretly generated code by the compiler, and just everything works magically. The beauty is you only have to write an absolute value function one time. If you have a bug in your code, you will find it. Whereas if you have 50 versions of your function, it's quite possible you will have a bug and not notice it, right? So this allows you to have your code. Does that copy pasting come at a performance cost? It does, but not the performance cost you think. It actually will slow down your compiler slightly. The big problem though with templates is that you can't do separate compilation with them, because you cannot compile this code. You can't put that into a CC file, right? There's hacks and ways around it where you actually sort of tell it, yo, generate the code for ints and doubles and floats and strings, but then your template will only work with those 4 types. So if you're gonna do separate compilation with templates, kind of sucks. It kind of actually really sucks. Basically, you can't do separate compilation whenever you use templates. Everything goes into the header file, which is one of the reasons why all along I've not been doing very much separate compilation with you and doing a lot of header-only stuff. Because guess what? If you look at Boost or whatever like that, you will have 100,000 lines of code in a header file because it's all templated. You can't do separate compilation with it. So it's a decision you have to make. Like, how important is compile time? And if you ever include, like, I don't know, Boost multi-precision or something, like, here, let me compile this code, time g++ main.cc. So that took 0.6 seconds to compile. Let's just include, I don't know, like CImage or something. Where is CImage? Yeah. Let's include CImage. Okay, highly templatized header file. Everything's in the header file. Can't do separate compilation. It's all templates. Including that one header file adds 3.4 seconds to the compile time for one header file. Okay, I'm not even using it. It's not even generating any templates using it. That's just the amount of time it took to copy and paste 100,000 lines of templated code and run through it. It's not even using the templates. It's not even generating code using the templates. That's just the time it took to parse it. And we can go down this route as a lot. You can go Boost, multi-precision. See what the actual include is on that. Yeah, let's do that one. Okay. So we'll just do some this thing right here, by the way, is for infinite precision arithmetic. So you can have infinite, you can have integers with no maximum value. Can you use that one template for an infinite number of functions? Yes, absolutely. And you can see that one header file is another second, 1.2 seconds or something. And so these things start adding up, and that's really a problem, right? Like it's a problem. And I'm not even using it. It's not even generating the templates or anything. That's just the time to parse it, because you can't do separate compilation anymore. In the traditional non-templated world, you have all of your function names just in a header file, and it just tells you this is the name of the function, these are the parameters it takes, this is the return value, right? Like old school header files are just something like this. There's a function named foo. It takes in a couple of integers. In fact, you don't even need to give them a name. You can actually just do this. And this says, tells C++ there is a function named foo that returns int and blah, blah, blah. So header files are normally just that, right? It's just a function name, parameter list, and return type. And with templates, you can't do that. Everything's in the header file, right? So locate cimage dot. I think it's user include cimage. So if instead of that, you get this. I'm holding down page down, by the way. I'm 20% of the way through the file. Right? Because everything in there is templated. You can't do separate compilation with it. There's ways of hacking around it, but then you sort of have to just specify which template instantiations you're gonna use. So yeah, it's all because of templates, and so it destroys your compile time. And so Boost, I love Boost. I've met the Boost people. I like them a lot. Everything in Boost is templated, and so every time I use Boost, I'm just kind of like, my compile time, So, yeah. So it's one of those things. It's something you want to think deliberately about, rather than just always template everything, right? Like a question is, an easy thing is like, does this function need to work with multiple types? If so, you template it. Simple as that, right? But if you're making a function that like takes a monster as a parameter, and it doesn't make sense to pass an integer in, right? Because it's going to set the monster on fire or something. Like you can't set integers on fire. Why template it? You know what I mean? Do separate compilation. And so there's definitely a trade-off in C++ between these different factors of like compile time, run time, programmer time, which is very important. You don't want programmers copying and pasting and wasting their time. Billable hours. Yeah, if you're a union, then it's a different story. I am a member of the union. I actually like our union on campus. They're good people. But unions do not encourage hard work. Okay. So, yeah. So that's templates in a nutshell. How about I show you once again the tree class that I made. So template class T works on either classes or on functions. Technically, it works on a lot of things, but those are the two areas where you typically use them. They work on lambdas, for example. I guess it's a function. So, yeah, and so my node class can work. It can be a binary tree of any type. Okay, so it can be a binary tree of integers or chars, whatever type you put in with the angle bracket there. It will substitute in that type for T, and so my constructor takes a T, my search function takes a T. I don't have a getter, but the getter would return a T. Aaron muted. Okay. You see that? So nowhere within the code is it hard-coded that I am doing a binary tree of chars. right? Everything just says, what is the type of X? T. To be determined. Okay. So, now, here's the thing. Will it work with every type? No. I mean, yes, but no. Well, yes, but actually no. So, check it out. I'm comparing X to data, all right? So this will only work on types where a double equals operator is defined. Does that make sense to you? And this works with every primitive type, integers and chars and floats and doubles. All of them have double equals compared, and all of them have the less than operator defined for them, right? You guys understand? But if I made my own class and I tried to put my own class into this binary search tree, it wouldn't work unless I declared and defined a double equals operator and an operator less than. You guys understand? I don't need a greater than. I don't need a greater than or equals to. I don't need a not equals to. But I do need those two. Okay. Professionally, do most people use separate compilation? Great question. This is one of the things that people will endlessly talk about, right? Because it's a trade-off, right? And so there's not like a right answer on it. Everybody wants to have instantaneous compiles, like we've been doing in this class. We compile things that are built in half a second, right? You try something, you compile it, you test it, you go right back into coding. Nobody wants to sit there and be like, compile, all right, wait a minute. Okay, now run it. Oh, it didn't work. Right? So, like for your image processing assignment, I reworked the, I actually rewrote all the code. You guys didn't know this because you hadn't taken me before. But for the image processing assignment, if you had me for 40, which maybe some of you didn't, for the image processing assignment, if we make clean and time the make, "25 seconds. Separate compilation is use of makefile. Separate compilation is when we do this. When you have a .cc file and you turn it into a .o file, and then you've saved that, right? So you don't have to compile it again. Now, let's say that I modify filter 1, right? Not time. Touch filter 1.cc. Now, if I if I rebuild, check this out, Hesterberg. It took 1 second to rebuild. And the reason why I didn't have to wait 25 seconds again was because when I compiled it the first time, I did separate compilation, right? So what I did here was I saved the results of the compilation using -c. I saved the results of the compilation of main.cc into main.o. Okay? And I saved the results of filter1.cc into filter1.o. And I saved the results of filter2.cc into filter2.o. So when I modified filter1.cc, I only had to recompile that one file. And it took 1 second instead of 25. And so that means my development process, where I'm going to be working on one file over and over again, I keep editing filter1.cc, compile, filter1.cc, compile, filter1.cc, compile, 1 second, 1 second, 1 second, instead of 25 seconds per compile. Okay, so that's separate compilation. You cannot do this with a template, right? Let me be clear. Template code goes into header files, right? So you cannot do this with just like a template by itself, right? The template goes into the header file, and then a .cc file includes the header file. See, we're doing separate compilation here with templates, but I'm saying the template itself cannot be compiled because it doesn't have any type information. Do you understand? It's like I can't compile cimage, right? Cimage, the header file has a bunch of templates in it. You can't compile that into a .o file. You can't. It is always just going to be a header file. And so every time I use cimage, it will include 100,000 lines of code and parse it and generate templates for things and cost me, 25 seconds of my life, literally every time I compile a file using cimage.h like that. Okay? So how I rewrote the code for this last semester when you all were doing this was before filter1.cc needed cimage.h. So the way that I had it before was filter1.cc, this file here, would include cimage.h. And then it would take 25 seconds to compile. Every time you made a change, it would eat up 25 seconds of your life. What I changed it to was, instead of taking a cimage image object, instead it passes in a vector of vector of vector events by reference. And I did that deliberately, because then filter1.cc only needs to know what a vector is. It doesn't need to know anything about the cimage library. And so what I did was I very carefully separated the parts of the code that knows about the cimage library. The cimage library does things like reading and writing JPEG files. I don't want to write that code. Do you want to write that code? I know I don't. So the cimage library, you pass it a file like harambe.jpg, and it gives you a 3D array containing all the red, green, and blue data for every row and column. And so what I did was I basically isolated everything that has to do with cimage into main.cc, and then basically tell my students, don't mess with main.cc. You compile it the first time, it's going to suck, it's going to take 25 seconds. After that, you don't have to compile it again. And it's compiled. Separate compilation is beautiful. So I was able to take students' development time from 25 seconds per compile to 1 second per compile. And so to answer your question, Lopez, that's the kinds of discussions that we have. Like, is there a way that we can isolate this header file that sucks? And it doesn't suck. It's a great header file. cimage.h is great, but it's 100,000 lines of code and it slows down our compile time. So can we isolate the header file, and instead of passing around cimage objects left and right, pass around like a vector of vector of vectors, right? Performance is probably worse. The actual running time of your program is probably slower, probably noticeably slower, probably like a second or so slower every time you run it. But the compilation time is much faster. So that's a trade-off. That's what I mean. It's all about trade-offs between all these different things. This is also what you did when you were refactoring the Bridges Andrew assignment to get the compilation time down. Yeah. So I try to isolate any slow header files into their own thing, compile that into a .o file using separate compilation. Right? Oh, yeah. So basically, my make file turns each of the .cc files into .o files. But because I've sort of only one file knows about that header file cimage, all these other ones can be recompiled very quickly. And pointers are actually used a lot in those regards. Pointers, you can just return a pointer to a chunk of memory and then mess with it. That's very commonly used to speed up compile times. Because a pointer is just a memory address. You can just take a memory address, right? And so by just passing a memory address to somebody, you don't need to have them include all this header file stuff. And so there's a lot of tricks people do, and that's like a whole discussion. But yeah, I will very often refactor code to make the code worse. Objectively worse. Like a vector of vector of vectors is slower than the cimage object. The cimage object is not you. And if you haven't done this assignment, it won't make any sense to you. But a cimage object holds image data, and it's just a 3D array. It's a one contiguous block of RAM, and it has member functions on it that do things like grab the alpha channel at this row and column, grab the red value of this row and column. It does a lot of cool stuff. It's got a save and it's got a load, so you can load JPEG files and save JPEG files, and it works beautifully. But everybody who uses a cimage object needs to include cimage.h, and then that takes your compile time down to like turtle speed. All right. So I wrote this function here, image2vec. It takes all of the data out of a cimage and it stuffs it into a vector of vector of vectors, because you can include vector with no cost, basically. Okay, so let's have you all do some lab time. So what I'd like for you to do is I would like for you to make a function t best of 2, taking in a TA and a TB. So this function here, best of 2, takes in 2 numbers and it returns, or it doesn't just take in numbers, takes in 2 anythings. Anything that has the greater than defined on it. And I should probably actually do this backwards, right? People tend to define the less than operator and not the greater than operator. So it'll work with any class that has the less than operator defined on it. So if you make your own class, like a class submarine or something, it'll work with it as long as you define the less than operator on it. Okay? So what I want you to do in lab time right now is make a best of, not 2, best of 3. Templated. Okay. What happens if you pass in something that doesn't have the less than operator? Great question. So you get what's called you guys ready for this? Template substitution error. Template substitution errors are the worst thing about C++. Hands down. Hands down the worst thing about C++. So, yeah, let's just do it. Let's just make a class. So struct Bob, and Bob's got, I don't know, int x and y and z. I don't know, it's called a point class, whatever. Called a point class, and there we go. There we go. And so if I say cout best of 2 for 2 different points, named, I don't know, 1, 2, 3, and 4, 5, 6, like that, won't compile. And it won't compile because there is no less than operator defined for this class, right? Make sense? So it's interesting that it's throwing an error there. That's kind of cool. So what it's trying to do is trying to copy and paste the best of 2 function, and it's putting in point for A and point B, but then it's saying there is no less than operator defined for this. Now, let's look at the template substitution error. It is the worst thing about C++. I'm about to flip a switch and turn Rant mode on. Okay? So, what the hell? What does the error message look like? It looks like it's sort of the equivalent of like when a rock star is on stage and they like lose control and they like start smashing their their guitar into the stage and like, you know, drive a motorcycle up and down a hotel room and things like that. That's the equivalent. Okay, you get error messages out of the compiler that make no sense whatsoever. And they scare the hell out of students because you just got, I don't know, how many lines of error messages we got. Let's count. So G++ main.cc pipe with the ampersand. Ampersand means standard error. All the error messages come on standard error. Pipe with the word count -L. So we just got 429 lines of error messages C++ when there should have been 1. And that error message was point doesn't have a less than operator. That's all I want to see. All I want to see is you forgot to do a less than operator on the point. You're doing a templated function, bro, that needs a less than operator. You don't have one. Make one. That's all I want to see from the compiler. Okay? I got 429 lines of error messages, and there is no compiler flag to turn those off. There are compiler flags for everything in G++. There's 500 optimization flags you can turn on and off. There's warnings for unused parameters and using parameters, and there's 900 million options for GCC. There's not one to just like turn off all the stupid template substitution errors. It is baffling to me how this has been a problem since the 80s. This is a known problem since the 80s and has not been fixed. Let's read the error messages. Let's see how much sense this makes. So what happens is you're a student, You're like, oh, welcome to C++. It's your first week of school, and then you see this. You're like, I must be the worst programmer in the world, right? I don't even know what's happening here. There's something about mismatched types, W char T and char, and you like Google this. You're like, it's a Unicode error. I'm getting Unicode errors, and maybe I need to turn on Unicode somehow. But then you look at this, and you're like, template argument substitution failed. What? Wait, const char 16. You scroll up a little bit, and you're looking at these things, and it's just like there's deleted thing. Did I delete something from an operator less double left? Did that not thing? You just keep scrolling, and you keep scrolling, and you keep scrolling. There's 400 lines of error messages, right? At the very top is the actual error. That's all I want to see. Actually, there's two. Right, so there's no match for operator double left arrow because I didn't do a double left arrow operator. And then there's also a problem with no less than sign, right? So let's do the operator double left arrow real fast. Friend, so we can just look at the less than operator. Friend, ostream, ampersand, operator, double left arrow, ostream, Bob, who cares? I can call you whatever I want. Const, point, by reference, P, cout, p.x, the space, p.y, the space, and p.z. And we don't want to cout it. Actually, that's a problem. Let's do Bob, and we'll just return Bob and call it a day. There we go. There we go. So that will solve our problems forever, right? Back to word count. Right? So I figured out the problem. 241 error messages remaining. Cool. All right, let's see this. Now we can see point is not derived from optional. That's the problem. Okay. So this is garbage. Like this is literally garbage. It's like you're having a stroke. Okay? There is absolutely no reason ever for the compiler to tell me, in my opinion, and my opinion is right, there is no reason for the compiler to tell me that point is not derived from the class stud : optional. I know it's not. It's a point class that I made. Why the hell are you telling me that it's not derived from optional as if that was an error? Right? It's not an error, it's a note. Right? It's just saying note. Because what it's doing, it's trying all these different things to make it work, and none of them work. And it feels the need that because it went to all that effort to try and make it work, it feels the need to tell you about every single thing it tried to try to make it work, but didn't work. Okay? You can return Bob on the same line. Yeah, because when you do a double left arrow, it always returns the cout. So when you cout hello world, that's an expression that returns cout. That's what allows you to chain together multiple double left arrows. And so you can just return that. So, yeah, and so for a computer science major who's starting off, they make the mistake of reading the stuff at the bottom instead of scrolling up to the top, right? So what you want to do whenever you encounter a template substitution error like this, which is garbage, and the worst thing about C++, what you want to do is pipe the results like this through less. Okay, you're going to lose the colors because less doesn't work with colors. But this is the solution, okay? And less shows you a page of errors at a time. And in fact, the only error that matters is the error at the very, very top, okay? Right here. Third line, error, no match for operator less than. Thank you. That's it. That's all I want. Stop. Stop, G++. Just stop. I don't need anything else. I don't need any of the, nothing else. Show me nothing else. Please, by default, just turn it all off. You've been exploding students' brains for 40 years now. I understand you went to a lot of work to figure all this stuff out. Just turn it off by default. If somebody really wants to see the notes, which they don't, trust me, ever. It's never been helpful in my entire life, the notes. They can turn it on, okay? Please, thank you. So, look at this. Look at this note that I'm getting here. Point is not derived from const stud reverse iterator. I know it's not. I know it's not derived from it because I made it. It's a point. It represents a point in space. Why the hell would you tell me that it's not derived from reverse iterator? I don't care. Nobody cares. It doesn't even make sense. Let's move on. It's not derived from a const stud move iterator. Okay, cool. What the hell does this have to do with a move iterator? Nothing. Nothing in my code has anything to do with move iterators. Oh, now we're talking about basic string views. Cool. Basic strings. No. Optional. No. I know it has no relation to these because it doesn't. You telling me this doesn't help at all whatsoever about anything. Okay? And we can just go page after page after page where it's telling me all of the things that it tried doing and didn't work. It didn't work with array. Cool. It's not an array. It's a point. What? It didn't work with vector. Okay. It didn't work with reverse iterator. Okay. Rant mode off. Maybe. It's garbage. Okay. Now, solution, pipe the results through less, scroll up to the very top, and at the very top, like I showed you, it will tell you the actual problem. Okay? Ignore everything after that point. It's good advice in general. Okay, so, yeah, if you ever try doing a template with something that doesn't work, you will get 5 million, 1,000 billion, jillion lines of error messages, of which one is useful. Okay. So, rant over. Lab time begin. Make a best of 3 function. Okay. I will give you guys 5 minutes to do this. Begin now. I'll pause the stream. Let's resume. Post your code up on the chat channel. And I'll give you mine. Alright. So we need a template. I'll do it with class instead of type name because they're equivalent. Best of 3, taking in a TA and a TB. And and a TC, of course, the tutorial center. So if A is greater than B and A is greater than C, return A. If B is greater than C, return B. Return C. And there we go. So we can do best of 10 and 20, 200 or something. Get 200. Okay. And then this would also work if we had floating point numbers, 10.1, negative 0.2, and I don't know, 100.77. And then I'm going to change the type here to be float, or, check this out, nothing. If you leave off the template parameter, C++, oftentimes, usually 80% of the time, will figure out, not always, 80% of the time, will figure out what type it is supposed to be. Okay? Sometimes, like, I've run into situations where it just really wants you to give it the type. Here, it's fine. You can do it anyway. It doesn't hurt anything, right? But here it's like, okay, well, you're passing in 3 floats, so I'm going to assume T is float. Okay? And it works just fine. So if we do this, you can see 100.77 is the greatest value. Okay? And you can delete this too if you want. It's all good. Now, this won't work if you do something like this. And this seems like it should work, right? Because like we've got 3 numbers here, right? It won't work. The reason why is because 10 is an integer. That's a float, and that's a float. When you do something like that, T is the same type for each one, and you're passing in an int and a float, and so it can't figure out, like, do you want me to do an int version of it? You want me to do a float version of it? Like, doubles, technically, right? Which version do you want? And it can't deduce it in a case like this. So in this case, you can just be like, yo, give me the double version of it, and then it will work fine. Okay? So, or if you wanted, you can make it the int version, and then everything turns into an int. It will warn, right, that you're putting a float in here when there's no point. You know, there's literally no, it'll compile, but there's no point. So the 100.77 turns into 100. So, or if you want, you can turn this into, I don't know, a long or something. You know, put in whatever you want, but in general, probably doubles the right move there. Okay, return the max of max. Yeah, that'll work too. Or if you're super awesome, you could do like a double ternary operator, right? So like return actually just do it like this. A is greater than B and A is greater than C. Question mark, return A, otherwise if B is greater than C, question mark, B colon C. I think I should do it. Let's try that. Yeah. Yep. The nested ternary operators just for maximum job security. Okay. Is template part of algorithm? Template is part of the core language. You don't need algorithm. You don't need vector. It's part of the core language. Literally, you can make any function or class templated, and that just means it'll work with any type. Okay. So it could work with strings. So you could do ternary operator is handy. I don't know. Maybe maybe it's handy. Maybe it's just job security. It's the kind of thing where you write it to make yourself look smart. Okay, so apple and banana and okay. Infinite job security list, right? So carrot is greater than banana and banana is greater than apple. So, okay. And that's with string class, which these are not, by the way. If we do it with a char star, I don't think this is going to work, actually. It'll compile, I think. I don't think it's going to work. Because it's actually comparing the pointers. It's actually not doing a string comparison. So this is the kind of thing where, like, the old C world comes back to bite you. So you really want to specify string here, or if you don't, what's going on here is it's going to be comparing the memory addresses of the pointers. Okay, I think. Let me just double check that. Yeah, see, banana is the greatest. What? What? I thought it was carrot. It's not doing. These aren't strings. These are not strings. These are pointers. They're pointers to blocks of memory. They're pointers to character arrays. Okay. If you did it with the string thing there, then it will give you carrot correctly. Be cautious. Be cautious. Beginning students, one of the things they always get wrong is they look at a string like this and they assume it's the string class. It's not. It's not. It's a pointer. It's a const char star. If you want it to be a string class, you can do a little s suffix like that. And then you get carrot. If you don't have those s's on there, you get banana. Why? Because it's comparing the memory addresses of apple, carrot, and banana, and guess what? Carrot just happened to be bigger in memory address. Yeah, be careful. It's one of the reasons why it's good to sometimes just, type it out, right? Type deduction for strings is something that always gets new students. All right, so how would you use a string variable for that? This is a string variable. If you manually specify string like that, then what it's going to do, it's going to construct 3 strings, one for apple, one for carrot, one for banana, and use the strings overloaded greater than operator to do the comparison. It's when you don't specify a type parameter that it's like, okay, well, clearly you want to be comparing const char stars. And so we're going to be comparing these pointers.
Some pudding?
Yeah, sure, I'll like some
just
pudding.
Just dump your hand and scoop
Put my...
Yeah, just like do it.
Give me a spoon, girl, come on. Is your hand covered in pudding?
Yes.
Do you put your hand into the pudding?
Yeah.
You have pudding on your face.
Mommy
That's your pudding now.
Pudding
That's your pudding. That's your pudding. Go. That's your pudding now. I'm all right. I'm good.
I washed my hands right before it.
I'm full. So thank you. Okay. All right. So let's do another example. So you all know, like, when you do like a vector of ints, right? That's specifying the type parameter. Make a point class that's templated. That should be easy, right? Point class X, Y, and Z, but allow it to work with ints or floats or doubles. Okay. So you understand? Like make a point class. Okay. The door opened by myself. Yeah. It's just Casper the Friendly Ghost. Okay. That makes sense? Can you put auto as your type? Yes, you can. Auto is essentially the same thing, right? So if you do like auto Bill's absolute value, auto X, return if X is less than 0, question mark, -1 times X, or X. Ternary operator again. And this is essentially the same thing as template type T. Okay. So I can see out Bill's absolute value of -10.1 and Bill's absolute value of -420. And you can see it works with floats, it works with ints. If you put auto here, this is modern. This is very modern C++. I think that's. I don't think that was allowed in 11. I think auto as a function parameter was like maybe 17, 14. All right, start working on the thing. I'll look it up. All right, let me unpause for a second. Yeah, auto was added in C++ 17. So if you want your code to work in older versions, you do it the old way. There's nothing really wrong with that, I think. The trouble is sometimes you want to just have T and be able to write T, like I want to make a variable named, you know, T, something. Sometimes you want to just be able to write that, you know, comes up a lot. If you're doing like classes, like you're making a data structure, your getter is going to return a T, you know. But for something like this, simple, like I'd probably use auto. There are ways of getting at the type of things. So decal type will return the type of a variable. And so this is as if if Babs down here is a double, decal type of X would be double. So it's making a new double named Y and initializing it to 10. And then auto is another way of doing the same thing. So this will make Z of the same type as X, which is kind of the same thing as this. I think a decal type auto actually works too in that case. Yeah. I don't know. Personally, like if you want to use T, like I would just do a standard template. But for short things, probably use auto. Okay. Continue. Another question is, how do you initialize a variable whose type you don't know? Like a lot of people want to do something like this, right? They want to write T Bob equals 0. Don't do that. I've been burned by this before. It's just habit, you know, just initializing things to 0. Strings can be initialized to 0. They shouldn't be, but they can be. And if you do, they segfault. And so my code worked fine until somebody substituted in string, and then my template very happily put string here for T and made string Bob and initialized it to 0 and segfaulted. And I'm like, what the hell? You know, like, oh, yeah, oops. So what you should do is this instead, and that will default initialize your variable of type T. Okay. Continue. All right, go ahead and post your classes. All right, so point class generally looks like this, right? Point, and we're just going to have like a point in space. Maybe we want to do like auto X, Y, and Z, something like that. Doesn't work though, because can't deduce those things here. So you do something like that. Template type name T or class T, either way, same thing. And then yeah, we could do like a distance function that returns like square root of x times x plus y times y plus z times z or something like that. So, all right. So we got point, I don't know, point royale. Initialize to 3 and 4 and 0. And we want to see out royale with royale distance. And so this should be the Pythagorean theorem. Z will be initialized to 0 because they didn't specify it. So this should print out 5. Squirt not declared. Yes, fair enough. Hashtag include CMath. When you type faster than Commander of Conquer of completion. Missing initializer for Z. Doesn't like that. Okay, that's fair. All right. 3, 4, and 5. Nope, nope, not GitHub. Nope. And we got 7 out of it, of course. Oh, because 3, 4, 5, yeah. 3, 4, 0. Okay. And we got 5 now. Okay, good. So that works. And now if we did this with like 3.1, it won't compile because now we have 3 different types here, right? So we need to make all of these guys floats, or doubles, technically. And it still doesn't like it. No valuable deduction guide. Okay. So let's make it a double. So it just knows what type it is. Okay. Like I said, sometimes it just doesn't work, right? So 80% of the time it can figure out. Yeah. 80% of the time it can figure out what to do. Sometimes though it just doesn't. So you just need to be willing to back up and just put in a type sometimes. Okay. Because I had 0. No, it was 0 dot. And 0 dot is the double version of 0. And so all 3 of these are the same type, right? For 3.1, 4.1, 5.1. But it still doesn't like it. So, yeah. G++ liked it, Clang doesn't, I guess. I don't know. All right, anyhow. So, this is not exactly what we want, though, right? I want it to work with any numeric type, but this will work with any type, right? What if I said make a point of strings, right? That's a problem, right? Yeah. Bob, Sydney, Alice, right? This doesn't work now, but I mean, maybe if we left that in, that it would sort of eventually we would figure out that it doesn't work because, you know, there's no plus, or there is plus defined on. Yeah, that's actually the worst part of it, right? Like if we just return x plus y plus z, right? It actually compiles, right? And it returns Bob, Sydney, Alice because plus is defined. Plus is defined on a string, right? So, oops. Right? See what the problem is? So, it's a problem. There are ways of restricting. There are ways of restricting templates that I kind of don't want to get into. So I'll just kind of leave it at that for now. Okay, but there are ways of actually enforcing this that this is a numeric type. But let's just leave it off for now. Now, it's absolutely garbage. So, is it complicated? Okay, so I don't know if complicated is the right word, but you can do things like this, right? Or like you have a you have a template, and you assert that the type is integral, and its floating point is arithmetic is the one I was thinking of, yeah. And so basically you can do that with a template, and then do a static assertion failure if it's not an. I'll post it on Discord. You can look at it if you want. So I'm not really going to get into it now. Now here's a problem. So best of 3. When we're taking primitives, works fine, right? Because you remember the rule. Primitives in general should be passed by value. Objects, things of class types, should be passed by reference. And we're passing these by value. But what if we passed in like an object? It would clone it, right? It would duplicate A and B and C and compare them, which is not efficient. So maybe we might want to think about like doing something like this, right? Where you pass them by reference instead, right? Now, I'm getting a compiler error. Can you not do templates with reference? No, you can. But it's not telling me what the error is. It's funny. Cannot bind a non-const L-value reference of type double ampersand to a value. So, that's also an int. So let's put that back into double format. Okay. Cannot bind non-const L-value reference of type double ampersand. So, there's a couple ways of fixing this. But why? What does this mean? What does it mean for something to be a non-const L-value reference? What is an L-value? What is an R-value? You guys remember that? If I say x is equal to 5, which is the L-value, x or 5? And which one's the R-value? Not left of an operator, because like 5 can go left of an operator, like. But left of an assignment operator specifically. All right, so if I say x is equal to 5, x is the L value and 5 is an R value. And the difference between an L value and an R value is that an L value is actually like a real variable. It has a spot in RAM that it has, right? The optimizer might eliminate it, but basically you're able to do things like, say, take the address of x, ampersand x. And that's what a call by reference parameter is. When you do call by reference, it takes the address of the variable and passes the address in. There is no address for a constant number like this. You can't change the value of 10.1. You can do that in Fortran. In old versions of Fortran, you can change the value of 7 to be 5. And then every time you use 7 in your code after that, it's 5. Because they don't have constants, they have variables. And so it's a variable named 7. And you can change the value of 7 to be 5. If you want. Just horrific. It's quite horrific. So the reason why you can't pass in 10 by reference is because you could change it, right? For one thing, right? Like you could change the value of 10, right? And so there's 2 solutions to this. First is to make it a const reference. If you make it const reference, it actually works somehow, right? And the other way is to do what's called a universal reference or a R value reference. There's a lot of different names for it. Forwarding reference is another one. Before you go on, do you understand why this doesn't work? 5 equals x. 5 is an R value, right? Can R values go on the left side of an assignment operator?
I mean, wait, 5 equals x is what?
5 equals x. I'm setting the value of 5 equal to the variable x. Can I do that, Ada? Can I change the value of 5?
Yes.
I can?
Yes.
You just heard me talking about Fortran, didn't you?
Hmm?
You can do it in Fortran. You can't do it in C++. Right? 5 can't change its value. 5 is an R value. 5 can only appear on the right-hand side of...
No, technically you can. I mean, it would take a lot of work because you'll have to convince a lot of people and you'll have to make inflation go up so that 5 can be worth less or more.
Thank you. So can I do this? X plus y equals 90. What do you think?
Can I watch TV?
Yeah, go for it. Can I set x plus y equal to 90? Does that even make sense? 5 is just a concept, yeah. Inflation. Can I do this? X plus y equals 90? Nah. Can't. because the results of expressions are also R values. They don't have a memory address. And if you really get into it, the L value and R value are old terms. They're still used, like you can see the compiler is using it here. But if you like really wanted to get into it, there's like GL value and PR values and X values. X values are expiring values, and there's a whole taxonomy of types now. X value is an expiring value. It's something that's going away. So like move operators are related to that. Yeah. So in general, the programmers just still talk about right R values and left values, L values. Okay. So now, so if we come up into here and we want to fix this, right? So one thing we could do is we can make it const. So if we make it a const reference, then it works. So it kind of figures it out. Well, you're not going to change the constant, so it kind of does some magic behind the scenes, and everything works. So would a variable made inside of a for loop be an X value? The bottom of the loop, if you're like returning, usually it's like when you're returning a value or like when it's reaching the end of its lifespan, something like that. It goes away when you got a scope. Yeah, it's not the kind of thing that I think you'll see like come up that often. So yeah, when you move out of it, it does have an identity, denotes resources. It's not very useful. Yeah. Basically, you don't need to worry about it. Like, just know the terms R value and L value because they come up in error messages and things like that. Okay. So if you make it a const reference, that works. But now let's say that we're going to be doing like, well, let me show you the other option. So this is something called a universal reference, like this. And universal references, when you do this with a template, it'll actually figure out if it should be an L value or an R value based on the parameter types you pass in. So if you pass in an R value, these things become what are called R value references. And if it's an L value you pass in, it becomes an L value reference. So this is something called like a universal reference. So if it can't be const for whatever reason, you do this. Okay. And it looks weird. I understand. There's 2 ampersands. I personally really don't like the syntax of it. It looks quite confusing, confuses people, confuses me sometimes. The rules on it, like if you like get into the rules of like, you know, how things work, like if you pass in a reference and there's reference collapsing and all these kinds of things, it actually gets quite complicated. Okay. It was hard to Google @hat. Yeah. Yeah, so you'll see move constructors taking these. They're used a lot in like forwarding parameters and things like that. Like if you take a bunch of parameters and you forward them to another function, you use the double ampersand, things like that. You can do a whole lecture on these things, but that's kind of that. Okay, so let's just do swap. Okay, that'll be our last lab for the day, and we'll call it a day. If you have any questions about templates, please post. But there is a standard library function called swap. Okay, so if we have string A equals apple and string B equals banana, if we swap A and B and see out A and B, cling D crashed. Fantastic. Okay, so if we swap the values of A and B, then A has the value of banana and B has the value of apple. Okay. So I would like for you to write swap, templated swap. Okay, so don't call it swap, call it swap. That way it won't conflict with the standard library. Make a swap function, templated, obviously. That's our lab today. That will switch the value of 2 parameters. Okay. So I will pause it and give you about 5 minutes to work on this, and then we'll call it. All right. Yeah, so the template type name T applies only to the next function or class. If you're going to do another templated function, then you have to type it again, and so it doesn't percolate through the entire scope or the entire file. Rather, it attaches to the next class or the next function you have. And this can be kind of annoying, like when you're doing like a lot of functions that are all templated, you have to just type template class T, template type name T every time, and you forget sometimes. It's fine. Not a big deal. Continue on. Right. So let's talk a little bit more about these universal references. What this is actually doing is that it's actually trying to figure out if the type of T should be like what. Like what is T exactly? And we're passing in a string reference, and so T is technically string reference. And so if you use T here, like this is saying, oh, that's a string reference named C, and you can't just have an uninitialized reference to something, so it doesn't work. So in this case, swap doesn't need to work on R values. You can't swap R values, right? So just doing it this way would be the way to go, I think. So. Apple, banana, banana, apple. Okay. Yeah, so there's no homework right now. I'm going to give you guys the weekend off. Enjoy yourselves. Have fun. Play video games. Elden Ring, whatever. The next homework assignment will be RTX on Part 2. So no worries. I'll give you working code or something. It'll be real easy. We've been talking a lot about trees and stuff like that. So it's going to be just doing tree traversal the proper way, because we kind of, like when we did RTX on, we kind of stopped, and I kind of stopped it because we hadn't learned trees yet, and really what we're doing with RTX on is a tree traversal. And so now that you know kind of how to do recursive tree traversals and things like that, we can actually do it properly with order, login, running time for the things, rather than order in, which we kind of punted on that one. It was hard enough as it was, so I just decided not to go whole hog on it at first. So don't stress out over it. It shouldn't be that bad. Use your own code from last time. I would, if it was working. If not, we'll figure something out, and it'll be partnered again. But if you want to spend some time on the weekend cleaning it up and making sure it works. Do you need a template above main? No, main is not templated. Main is not templated. So, just relax, have a good time. It'll be fine. All right, so here is a working swap implementation, and this encompasses, as Stepanov said, the essence of swappiness. What does it mean to swap something? Right? It actually doesn't matter if you're swapping ints, or you're swapping floats, or you're swapping doubles. It doesn't matter. This is how you swap something. You make a temp, you copy A into the temp, you copy B into A, you copy the temp into B. Done. 4 lines of code, it'll swap anything that has the equal sign assignment operator defined on it. Okay? So you'll get a template substitution error if the thing doesn't have an equals operator defined on it, and it'll probably confuse the hell out of you. You're trying to swap 2 points, and your point doesn't derive from the reverse iterator class, and it doesn't use Unicode, and we tried turning your point class into a stack, and that didn't work, and we just thought you should know because we tried, and we didn't want to go to all this work without you appreciating how much work we're going to. So we're just telling you about all the things that didn't work, that it might have been, but it's not. Yeah, kills me. Okay. So would you ever have template T in main? No. Main is main. It's not templated. So did you already rant on the template substitution error? I sure did. So yeah. So basically, when do you use a template? Whenever you find yourself about to copy and paste a function, and all you're changing is the type. If you ever find yourself doing that, your brain should go like, template time, and templatize it at that point. Until you need, like, if you got some weird thing that like probably just only takes one type, then don't template it, and then you can get the benefit of separate compilation and things like that out of it. Okay, so basically, it's like when you find yourself making a data structure, and the data structure could hold ints or strings or doubles or whatever, template it. If you're making a monster class that only takes monsters as parameters, then don't. It's a pretty straightforward rule. If you want your stuff to work with multiple types, template. If it only should work with one type, don't. There you go. That's the rule of thumb. So that's it for today. What if people were the monsters all along? Yeah. It's like the cover of Holy Diver, right? So there was, the panic of the 80s over all things occult. And so, like, people didn't like the fact that you had this monster, like, attacking the priest, and Dio was like, well, how do you know it's the monster? So... witnessed it in person, it was glorious. Yeah, if you want my blood pressure to go up. Like, because I'm the person who has to explain the errors. It's not the compiler people, right? Like, the people who write G++, they're not the people that have students coming to them with 500 lines of error messages going like, I don't know what's wrong, but I don't think I'm cut out for this computer science stuff. And I'm like, oh, you used 1 equals instead of 2. And they're like, oh. Why was there 500 lines of code? Or errors? I'm like, I don't know. But it's dumb. So, I think if the compiler people had to answer the Discord questions late at night, they might just give me the option of turning it off. I don't know. I haven't looked in the last couple of years. Maybe there's an option now. Who knows? But I did look several years ago, and there just was no option to disable the notes, which is baffling to me. Okay, so that's our class for today. C++ shouldn't be taught to beginners anyway. Like, if they just turn that off, like by default, like, there would really be no means to complain, right? Concepts are helping with that. So concepts allow you to do things like, say, stood integral, and then is it integral? Stood integral lowercase. Yeah. And now this will restrict the template just to integer types, things like that. So if you try that, then code still works. But if you try doing it with, like, I don't know, like a float or something, then actually no, it's because of this, right? If you try doing it like the float, like that, then it will complain, and it actually gives you a much more reasonable error message. So concepts are kind of the new thing. They're still sort of rolling out. Like, my Clang on the server doesn't support it, G++ does, but it allows you to see things like this: no matching function call, it requires integral, constraints not satisfied, and substitution requires integral. From here, required for the satisfaction of integral with t equal to float, but it's not an integral. So it kind of gives you a better message. It's still not the world's most readable, but basically it doesn't tell you it tried converting it into a vector or a reverse iterator or a move iterator or something. Like, it just tells you, like, you're trying to call best of 2 on a float, and float doesn't satisfy is integral type. It's not an integer. And so concepts have a great promise for getting rid of all those horrible template substitution errors. I personally think that the compiler people should just allow you to just not see them. That's my take on it. It doesn't make C++ students want to drop. Yeah. Okay, so that's it. Concepts are pretty cool stuff. You can look them up if you want. It's in #include concepts, and that's it's a new thing, C++ 20, and support is still spotty, depends on the compiler you have, but it allows you to constrain types in a very easy, like, you just say t must be integral. It must be an int or a short or a long or a byte or something like that. It's pretty cool. Gives you better error messages. So that's it for today. I see people are logging off, so thank you, and we will pick it up on Monday. There's no homework. Enjoy your weekend. Peace out.